energy and enthusiasm. We're going to deep dive into a comparative analysis which compares LLMs and AI agents. So it all starts with the question, what makes an AI agent acceptable? We have seen the rise of LLMs, part of the generative AI, which can understand the natural language and generate huge amounts of text. And then we've been seeing the thinking capabilities and reasoning capabilities of an AI, of an LLM. And now we are hearing this AI agents. Why do we need to adapt AI agents? It's not necessary that with all the new inventions or the advancements, we should shift to that advancements or the innovations immediately. But these AI agents or agentic AI systems have seen a rapid growth, or we could also say a rapid attraction. So, with that, we have landed at this question, what makes an AI agent acceptable? In this deep dive, we're going to see comparative analysis between LLMs and AI agents. Till now, we have seen agentic AI introduction, and then we have come to know how to build a simple agent using rule-based techniques, right? And from now on, we'll be diving more into the components of AI agent in each of the videos coming next in the series. This video is part of the Foundations of Agentic AI series and will be continued for the next 4 to 5 videos, which explains complete overview of this agentic AI foundations. In this series, we have covered this agentic AI fundamentals in the first video, and then traditional rule-based systems. We have built a simple agent using simple rule-based systems. And then today we'll be exploring the critical differences between LLMs and AI agents. In coming days, we'll be diving deep into this multi-agent systems and practical implementation strategies. With this, let's start our session. As usual, this is Harsha Kondaviti, directly reporting from DATAVALLEY's AI Center of Excellence. And we call ourselves the most eligible people to talk about agentic AI because we get our hands dirty daily implementing and experimenting the cutting edge technologies and experimenting with the advanced features we get from the topmost AI firms. So let's first understand what is an LLM as part of our comparative analysis or comparative deep dive. And LLMs are more of the models that have been trained on huge amounts of data, right? As we all know, when ChatGPT was released into the market, it was like a boom, right? We never know. We were never thinking about such kind of innovation or such kind of advancements in the field of AI. We were never prepared for that, but still we have seen that, and it has gone under different uh, iterations of transformation and improvements, where it has been trained on different new kinds of data, new types of data, or different amounts of data. For example, till 2020, we have seen that ChatGPT responding to the questions that it has got enough amounts of data to be, that was trained on. And later, in 2022, we have seen that ChatGPT has knowledge till 2022. And then later, in 2024, it has got capabilities of searching online and giving the information. So it is more of like LLMs over the period of time, they need data to learn. They improve themselves by learning from the data, And similarly, companies have been feeding the LLMs with the data they have, and over the period of time, LLMs have been improved. With all the experience, these LLMs are capable of generating human like responses, generates text that mimics human writing and conversation patterns. So, of course, nowadays, most of the people are facing issues with the artificial text that has been generated by these AI applications. But we can just fine tune the responses generated by the AI applications in such a way that we can ask them to give us the responses in such a way humans converse or humans talk. And popular examples for these LLMs or LLM applications are ChatGPT, the first LLM application, and GPT-4, the most sophisticated model, large language model, and similar AI models from leading AI labs such as Anthropic, Midjourney, or Mistral, or you can also say this XAI, which is the proprietary of Grok models. And then we have this DeepSeek, which is open source model, open source organization that provides us DeepSeek reasoning and search models. So there are versatile applications which are great for chatting, which are great for writing, which are great for even coding, and the language based tasks. For example, if you want to get a task done where you can just give simple instructions in the natural language, that's where we are seeing the rise of AI agents, and we'll be diving deep into this AI agents in coming videos. So, but just to understand, we have already seen this what exactly is an AI agent, but for comparative analysis, we'll be just going through this, uh, the fundamental introduction. What exactly is an AI agent? It was built on LLMs, which was added an extra features called autonomy, tool use, which is in simple terms also known as APIs, and we have the reasoning capabilities. That's where we are able to integrate AI agents into the workflows. And we have also given the feature memory, which is the most powerful features that has AI ever has seen. And then these are not just text-based assistants or chatbots. These agents act in the real world based on the given instructions. So if you want to understand more about each of the features that compares with the LLM, you can have a quick quick look at this foundational video that we have already created, which is the first video. You can just go back. We are also tagging this video here that explains a deep explanation of agentic AI fundamentals, right? So we have seen introduction to LLM and introduction to AI agent. But what exactly is the difference between LLMs and agents? LLMs are more of text generation models, which has got capabilities of predicting the next word from the given word. It is more of like similarity calculation and then predicting the next word in the series or series of words. So it has got no real world action. It just responds to the user input, right? So it's more of like text generation or text creation or a kind of predicting the next word in the series. That's how it works. And the most sophisticated LLM comes with the feature of low latency, which means less response time to the user queries. So the most efficient LLMs refer to the LLMs which take less response time to respond to user queries, which means the most efficient calculation has been done in the background so that the next word is predicted in such a way that it takes less time. But when it comes to agents, the most important feature is that autonomy. We talk about autonomy. Autonomy refers to automated actions taken by the agents while they have got thinking capabilities. These thinking capabilities enables the reasoning. Reason is such an important thing these LLMs use or agents because agents have got the brain, which is nothing but the LLM. These LLMs are capable of thinking and reasoning, and this reasoning feature is such an important thing such that these agents use this reasoning capabilities to justify their action. Agents perceive the information from the environment and plan the tasks automatically and then executes the tasks in the same environment in which they are acting. Everything is automatic because agents have got the thinking capability so that it can think, analyze, and then plan and then execute the tasks. So it's all happening because of this feature called reasoning. That's why we can trust these agents because the reason that why they have taken particular action based on the information that they have gathered from the environment. So agents are capable of executing the tools through which they take the actions, or we can also say agents take actions through the tools that they have access to. Tools are more of like API calls or implementation of the external applications. We can simply say executing the external applications via the APIs are known as tool calling. And while the LLMs have got these capabilities of function calling or tool calling, which OpenAI has introduced first, and OpenAI models are excellent at function calling or even executing tools. And this has been adopted by every other model there in the market. And then later, these researchers have given these AI models the reasoning capabilities. Out of all the thinking and analyzing capabilities, they have expanded the capabilities of the LLMs to the next level where they have included this reasoning capability. This reasoning capability enables LLMs to justify their answers or the plans or their thinking process. So the major difference is LLMs are merely for text generation, and nowadays LLMs have got search capabilities in the background. They're just calling Google search or some kind of web search tools which gathers the information from the web. So while LLMs have got the thinking capabilities and search capabilities, indirectly search capabilities refers to the function calling or the tool calling, right? So in such a way that LLMs have been transformed or extended to the AI agents, where agents are capable of taking autonomous actions and reasoning. So with this reasoning capability, they can just plan the next actions and take actions, and based on the actions they can get the feedback, and based on all the feedback and instructions and the information they perceive from the environment, they justify the action that they have taken. So that's the main thing. We have been developing AI agents and trusting them blindly. Nobody knows what happens under the hood. Everybody is excited to build the agents, but the thing is, in the background, it's all about the LLM that performs well. That's the only thing we can trust in the entire agentic system. With that, we have these real world examples. For example, if you want to search for the weather in New York, LLM It's mostly like it will be generating the example or example response like usually sunny in June. So it has the historical data where it has been given some information like New York experiences sunny weather in June. So it usually generates from the existing information such as usually sunny in June. It's more of like providing a generic response based on the training data. What if it doesn't have the live data? For example, still now, LLMs are just capable of trying generating a text from the existing data or the trained data. They're not capable of getting the information from real-time web. So that how can we just know the real-time data while we ask questions to the LLMs? That's where, with the integration of tool calling capabilities to these AI LLMs, large language models, LLMs have been transformed or extended to this AI agents or agentic systems, where agentic systems are more of like having these LLMs as the brain, and this brain has got capabilities to execute external tools which gather the real-time information. Similarly, in case of agent, while implemented for the same example, it's going to respond in such a way that it's 25 degrees Celsius and partly cloudy now. So which means it has executed the real-time API, which called some other external tool, which gave this agent some real-time information, and it has understood that it's 25 degrees Celsius and partly cloudy now. So which means agent has executed some external tool to retrieve the current information. That's the major difference. LLMs just generate the text. Agents get the information from the web in the real time. So that's the major difference, which means we need to understand that underlying concept is tool execution rather than information search. Agents can connect with any application ranging from information search to kind of posting something online or even booking a ticket or even booking a slot in your calendar or even sending out mails or even kind of performing content analysis, so that we got a lot of examples or use cases within different industries and different teams. With that, let's understand the anatomy of an AI agent. So we have seen the difference between LLMs and AI agent, but let's understand the anatomy of AI agent that makes a huge difference from LLMs. Agents are more of like goal oriented. So agents are capable enough to perceive the information, and based on the perceived information, they can just analyze the data or information and then process a plan. Based on the plan, these agents are capable enough to execute a task. Before executing a task, agents need to set a set of goals so that one set of goals are planned, it can keep executing the goals or the tasks which are planned as per the goals. In order to execute these tasks, we have these tools which I have already discussed earlier. LLMs have got these tool execution capabilities so that these LLMs, when integrated or extended to next level AI agents can simply use tools to get the task done. To get these tasks done, LLMs needs to execute the tools in the background, which are so-called API calls. And then these API calls are nothing but integrations to the external applications where actual tasks will be performed and the output will be shared to the agent. The third most important thing is reasoning. As we have already discussed, when LLMs have been given some reasoning capabilities, they're able to justify their actions or justify the response that they give. When they justify their response, they are also capable of justifying the action that they take because LLMs have got tool execution capabilities. But the thing is, still, LLMs are capable of perceiving the information, or the agents are capable of perceiving the information. They're capable of planning the tasks, and then they're capable of executing the task. But the thing is, what makes them so reliable that they keep a track of every single step that they make and learn from historical data? That's where we have given them the amazing feature called memory, where every single thing that the user interacts with the LLMs has been stored in the memory, which is also known as persistent memory. So these agents, when integrated with the memory, they store the state transactions, in the sense when the agent executes a particular task, it's going to store the state information. For example, it moves from one state to another state when executing the tasks. So in such a way that while executing the tasks, it is going to store every single piece of information at every stage in the memory, so that it can trace every single step while taking the next step. So in such a way, LLMs have been developed and extended to AI agents. AI agents have been improved daily basis to perform or to mimic humans at the workplace. So that's what we are going to see, witness in coming days. But we have seen the amazing features of AI agents. But how are they going to work, or what exactly is the workflow in which they're going to work internally? So, first one is agents perceive the information from the environment, they set the goals on their own, and then if some information is not needed, I mean, some information is lagging, they'll get the info from the external APIs. For example, in this case of um, planning the New York City's trip, let's consider this example of New York City's trip. So in that case, it needs to have some external data which is related to New York City from tourism APIs or travel APIs to plan the travel as well as to search for tourist places. In that case, it would first set the goal to plan for New York's trip, right? So in that case, the next step it has to do is to search for relevant information from the web to plan a better New York tourism or New York trip. So in that case, it gathers the info from the web, which is nothing but tourism APIs and other APIs to search for the weather conditions or to search for the hotels availability, to search for the flight availability, to search for the um, different tourist attractions in New York City. And then it would prepare a plan and then apply reasoning to justify why it has planned in such a way or why it has given a plan. And later, once the justification is done, it will send out the plan to the user. So that's how agents have been developing over the period of time. And it is all because of the tool calling ability or function calling ability that was given to the LLMs. And this was all risen with chat GPTs or the GPT models that have got great tool calling capabilities. We would like to emphasize this tool calling capabilities because LLMs till now are capable of understanding the natural language text. But with this help of tool calling or function calling, LLMs have gone to next level. You can't even imagine. That's where prompt engineering has got much importance to tell the agents or LLMs to execute tools and the process to execute the tools. This is going to next level. That's where we are seeing the AI agents. and multi-agent systems that we are going to explore in the next few minutes. But how did these AI agents evolve from LLMs? So LLMs are just the core component in the agent or agentic architecture. Agents are a combination of large language models, tools, memory, and autonomy. Memory is all about storing the historical data, and tools are all about capabilities. It's more of like API calls or function calls. And autonomy is what changes the game. Autonomy comes from prompt engineering because we gave automation capabilities or automatic um, acting capabilities to the agent within the prompt itself. So, two main reasons that fueled these agents or agentic development. First one is advanced reasoning, second one is tool calling. So, as I have already mentioned, and as I would like to emphasize the need for learning this tool calling and advanced reasoning are two features that changed how LLMs think and how LLMs power agentic actions in the real world. And there are a lot of frameworks to develop these agents or agentic applications, out of which LangChain is more recommended for enterprise grade, robust LLM or agentic applications. And Crew AI is more of like beginner friendly at sophisticated agentic development framework. So, with this, you can understand LLMs are not equal to AI agents, whereas AI agents are the extended versions with integration of tools, memory, and autonomy features. And we are not only experiencing these AI agents, AI agents are more of like standalone agents. And we might think AI agents are not no more, it's like not different from they're not different from these LLMs. But think of having multiple AI agents working together in a team where we call it as AI workforce. Soon they are going to join us. By this time, we have been already integrating AI agents into our workforce, AI agent teams into our workforce, which we call it as multi-agentic teams, right? Multi-agent teams or systems that have been actively participating in daily tasks in an organization. But why do we need multi-agentic systems? Because think of some organization structure where we have team members. Let's consider a project development. Within the project development itself, we have development teams, testing teams, deployment teams, and the one who works on the feedbacks or new features. And in the real world itself, while collaborating with the people, while working on the tasks, we collaborate with people and get the things done. LLMs, which were developed by human, they need more assistance, and they tend to work in teams to achieve complex tasks in a simple way. So that's where we have been experiencing these multi-agent systems. We have also built several multi-agent systems at Data Valley, and out of which we've been implementing few use cases. First one is student support system using agents or student support team, AI student support team, where they are more of like assisting students with their assessments, assignments, and creating their personalized learning path. And on the other hand, we have this marketing use cases where our agents are capable enough of um, performing content analysis, content creation, right? So we have 13 agents deployed for performing content analysis and content creation. And we have the customer support AI team. So they're more of like handling the tickets and escalating the complex issues to our managers. So these multi-agentic systems collaborate in terms of intelligence. Multiple agents work together with specialized roles to solve complex problems collectively. One complex problem cannot be solved by one single agent. Even in real world, we need assistance or support from our team members. So in that case, we would say agents can collaborate in terms of intelligence and get the things done in a most simplest way. And we have been seeing, as I have mentioned already, we have been implementing agents in multiple use cases. Part of that, the biggest firms in the industry have been already implementing AI agents. And there is a statement from the IBM developer, the AI strategist at IBM. They said those who do not implement AI agents or learn AI agents will lag behind, right? So it's time to learn AI agents, but still, why AI agents are the future? Till now, we've been experiencing the LLMs, and so many people out there do not know how to chat with LLMs or how to make these LLMs work for them. With that question, why do we need AI agents? Are we prepared for the AI agents? Obviously not. We have found this rise of AI agents in the month of November, and then we have expected the boom within next 2 to 3 months. And then there we have these people talking about the AI agents, even the non-coding people or non-IT people who have no coding experience. They have also come out, experimented with AI agents, and they have seen amazing results. And they were talking about the AI agents and agentic AI development. It's all because they have seen results good enough to talk about them. It's all because they're efficient. AI agents are always efficient in the workflows. And then we have the autonomy where the tasks where humans are not needed or less human intervention is needed have been already automated so that humans can focus on most complex tasks or the most tasks that need most of the attention. And with the agentic systems where multi agents have been implemented, there is a scope for scalability within the organizations without any doubt. So, with this scalability feature, agentic systems are capable of handling multiple tasks at a time. I'm not saying that single agent can handle multiple tasks. The only thing is, with multiple agents in a team, multiple tasks can be distributed among the agent team and they can get the tasks done on their own. Till now, we have seen the LLM applications, but now we have been seeing this agentic applications. So that's how it's going to change the world. With all the innovations and trends, it comes the most hidden challenges. Those who implement the agentic applications or those who create the agentic applications might not be experiencing challenges with the hidden LLMs or the efficiency of the LLMs. The one who is actually building these LLMs might be facing issues with the LLM's execution in real world. So, one of the challenge that we have faced being the developers in the industry, we face issues with the context that has been given to the LLMs. Because LLMs are capable enough to understand humans' natural language, humans' instructions. But the thing is, to execute a task or to reason enough they need more detailed context. That's where context engineering comes into the picture. And to make these agents work in the real world, we need sophisticated systems as well as better instructions. I stress it, better instructions. LLMs won't understand some simple prompt or insufficient instructions or limited prompt. Sometimes we might ask LLMs about a question or about some topic like, what is this? It wouldn't give much context to the LLMs when you simply say, what is this or what is that, or, what is the topic or something like that. You need to give detailed context to make it work for you, because LLMs have been trained on the huge amounts of data, where somebody who has seen a lot in their life, when we ask them for something, they would analyze the simple question in the most complex way, and they would give the most complex answer, which the one who asked the question might not like. Similar to that, agents have, or LLMs have already seen a lot of data you can't even imagine. From that, we need to bring that LLM down to our perspective or to our level where we ask the question, so that it would get more context about the question. Based on that, these days it can think, it can reason for the answer that LLMs give. So these are few challenges, and the emerging trends forecasted more of like multimodal AI capabilities. It's more of like LLMs that deal with multiple types of data like image, audio, video, or even text, right? And LLMs have been dealing with the code as well. Of course, code is end of the day treated as the text only, right? And then later we have the vertical AI. Mark my words, vertical AI is going to rule at least for the next 5 years. Vertical AI is going to boom with AI engineers working on the domain specific AI systems like healthcare, pharma, finance, marketing, agriculture, whatnot. So vertical AI agents are going to boom in near future, maybe in a couple of months, I would say, so that sophisticated domain specific applications of AI agents or agentic teams will be rising very soon. But what exactly are the key challenges? To train the agents or even the LLMs specific to the domains, we need robust data or proper data to train these LLMs and AI agents. With the domain specific applications, there comes the excellent challenge. It's data privacy and system governance. System governance refers to LLM application governance or AI governance. We call it as collectively. So, more of like how these AI applications are performing under the hood. Understanding how these AI applications perform under the hood is the most important thing that leads us towards the explainable AI and responsible AI. Mark these two terms. These two terms are going to rule the AI industry in coming years. AI agents are getting capable enough to deal with external tasks in real world, but people preparing for trusting these AI applications is what matters in near future. To enable that, we have this explainable AI with the help of reasoning and responsible AI that answers to the questions and also explains why the answer is correct. Over this, we have this AI governance. Developers users, or even the engineers who deploy the models or who deploy the applications to the endpoints, these people have to look into the underhood process that explains how these AI agents are thinking and taking the actions based on the information they have. And then humans have got emotions. Humans consider ethics while doing certain things, but AI developed by humans needs to follow the same direction in such a way that these agents or AI applications or even the LLMs think and act in the real world, mimicking the human actions. To trust these AI agents or even the LLM applications, we need some integration of ethics to these LLMs and AI agents. So, there we come to a consideration of integrating ethics into the existing systems, AI applications or AI systems, to enable autonomous decision making. We cannot trust the autonomous decision making unless we implement three major things. First thing is explainable AI, second thing is responsible AI, third thing is ethical AI. Mark these three terms, these are going to change the industry or the perspective at which developers, AI engineers, or even the AI practitioners, AI strategists are going to look at this AI in the near future. So, if you have any questions, just drop them in the comment section. We are happy to answer in the comment section. So, in the next videos, we're going to come up with the more deep dive videos, deep dive explanations about context, memory, tool usage, etc. etc. So stay tuned to Data Valley. And to summarize the key takeaways, we have gone through comparison between agents and LLMs and real world impact of AI agents in different use cases. And with that information, we mark the year of 2025 as Agentic Year. Next, we're going to dive deep into this how AI agents think. We're going to explore each of the feature that was added to the LLMs to make them AI agents. Part of that we'll be diving deeper into this thinking capabilities, and then we'll be going through the tool usage capabilities, and later we're going to have this memory, which is also referred to the context storing capabilities. Right? With this, I would like to emphasize the need for learning AI agents and playing with LLMs whenever you get time. All right. Thanks for watching. Signing off, Sai Harsha Konveti from Tita Valley's AI Center of Excellence. Thank you.